Let's take a look. This is a limit. What do we have to do first?
Plug it in.
Plug it in. So, where is this going?
1.
Very good. Where is this going? Remember, cotangent x is cosine x over sine x. What is the value of cosine at 0?
0.
Cosine at 0.
1.
1. And what is the value of sine at 0?
0.
Yes. And this is trouble. Both are positive. Where is this going? And they're both positive. And 0 from the right, first quadrant. They're both positive. One over 0, both positive. Anyone?
I thought this was undefined, so I don't know.
But we had a situation a few minutes ago. Negative 2 over 0 is no different from 1 over 0. And they're both positive.
Infinity.
Infinity. Thank you. Awesome. So look at that. Trouble. Double trouble. Okay. So this is a long procedure. This is not a friendly situation. Powers are not friendly. Infinity minus infinity, not too bad. 0 times infinity, not too bad. 0 over 0, infinity over infinity are the best, but powers are not friendly. So when we talk about powers, is there anything connected to, do you remember what we said when we differentiate a function raised to another function? What is the rule for this?
Natural log.
Exactly, no rule, but a two-step procedure. Same thing here. It's the same idea. It's a function raised to another function. A function raised to another function. We have to take the function out of there, and we have to denote it by 4x, so by y. So this is 4x plus 1 raised to cotangent x. In step 2, yes, like before, we have to apply natural log. Natural log y equals natural log of 4x plus 1 raised to cotangent x. How do I simplify this? What is the next step here? Natural log y equals?
Cotangent x.
Yes.
Natural log.
Yes. Good.
That's all one step though, right? Like that is applying
You can,
the log.
yeah,
Okay,
because that's yeah. You can consider step 3 if that's what you want. It doesn't matter. Or you can consider step 2a, 2a, 2b. Yeah. Number 3. We apply the limit as x approaches 0 from the right to both sides. So limit as x approaches 0 from the right of natural log y equals limit as x approaches 0 from the right from this product, cotangent x times natural log of 4x plus 1. And I know you're going to say, and before you say it, I'm going to be proactive. Yes, we are not asked to find the limit of the natural log of this. No. then why am I applying limit to both sides? Because there is, I shouldn't say there is no other way, but that's the easiest way. And you will see what happens next. Yes, I know we're not asked to find the limit of the natural log. We will, and then I'll explain next what follows. Okay, so I continue. This is equals, 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 equals. It's okay. At this point, I have to see what's happening here. So let's start with the easy part. When x approaches 0, where is this going? When x approaches 0, where is this going?
One.
Good. How much is natural log 1?
0.
Perfect. Awesome. Excellent. We already know that when x approaches 0, we already did this 5 minutes ago. When x approaches 0 from the right, you already told me that this is approaching infinity, so I'm going to write it here. I like this better, much better than this, because 0 times infinity only requires an algebraic manipulation. Rearrange the function. Do something to it. Yeah, I will. Do not touch the natural log. In other words, we're not going to do anything to the natural log. Do not drop the limit operator. We have not applied it yet. Okay. So I'm going to write natural log of 4x plus 1 over tangent x. And you can say, how did you come up with that? Because I know that cotangent is 1 over tangent, or 1 over tangent is cotangent. The reason I did this is because I'm hoping for this now. We already know the natural log goes to 0. That didn't change. And replacing cotangent by 1 over tangent, tangent x approaches 0 approaches 0. Yay! Why? Because now I can apply L'Hopital's rule. Excellent. So then I have limit as x approaches 0 from the right. Can anyone differentiate the top for us? And somebody else the denominator?
Four over 4x plus 1.
Yes, so we have 1 over 4x plus 1 times the inner function prime. Awesome. Can anyone differentiate tangent for us?
Is it negative cosecant squared?
Just positive.
Oh,
That's cotangent. Cotangent prime will be negative cosecant squared, but tangent prime is secant squared. Good. Can anyone tell us where is the numerator going as x approaches 0 from the right?
4.
Excellent. Can anyone tell us where is the denominator going? Remember, secant squared is 1 over cosine squared. Where is cosine or cosine squared going as x approaches 0?
1.
What is the limit then?
4.
4. Is this what we are looking for? No. No. We're not done. In step 4, we are going to copy, I am going to copy the beginning of step 3 and the end of step 3. Copy beginning plus end of step 3. Nothing else. So we had limit of natural log y equals 4 as x approaches 0 from the right. A very long time ago in chapter 2, we talked about briefly about swapping the operators under continuity. This is the time to apply it. These are all continuous functions. I will move the inner operator out. I will move the outer operator in. So natural log of the limit as x approaches 0 from the right of the function we are looking for is 4. Now, let's solve this logarithmic equation for this. Natural log of something is 4. Remember, the base of natural log is e. E to this power is this. So we got our limit. Limit as x approaches 0 from the right from 4x plus 1 raised to cotangent x. Can anyone give us the answer? And this is final. So
E to the 4.
yes. So you can make this, if you would like, step 5. Swapping the operators. And this is final. So, again, how many steps? A million, a zillion, all sorts of steps. So first of all, I plug it in. I realize it's one of the most cumbersome, a power. I know I have a function to a function, and I know that there is no rule. You can say, how are you relating differentiation with this? I'm not. I'm only stating that when a function is raised to another function, the two-step procedure applies again, but not two, but many. But the two-step procedure, I'm really referring to applying natural log. So they're not connected, but they are in the sense that I have a function raised to a function. I have to apply log. That's the connection. So we apply log to both sides. Then we brought the cotangent in front because it's a property of the log. Then we apply the limit to both sides here. We continued, we simplified, we manipulated, we applied L'Hopital's rule, and we got a number. Then we copied the beginning of step 3, and we copied the end of step 3. Nothing else matters anymore. Now I'm allowed to do the swapping of the operators because all these functions are continuous. So the inner operator, the natural log, has to be applied to y, and then the limit. That's the correct order, but I'm allowed to swap them. And when I swap them, all of a sudden I realize that I have a logarithmic equation. And this logarithmic equation can be easily solved by saying that this is e to the 4th. E to the 4th is this. And this is what I'm looking for. The limit of 4x plus 1 raised to cotangent equals e to the 4th. Yes, another situation with zillions of steps. But it will, once we look at the first one and the second one, then it will become easier. So the floor is open for you. You choose any power you like to work on. And then we'll look at the discussion and the Newton's method that was suggested at the end.
This is section 4.8, right?
This is section 4.4, L'Hopital's rule, and indeterminate cases. So will anyone
Can we do
else?
64?
We want to look at 64. Very good. X raised to e minus x. Perfect. 64, limit as x approaches infinity from x raised to e minus x, and this is my page 8. Okay, perfect. First step first, what do we need to do first here?
Okay.
Good. So when x approaches infinity, then x approaches infinity. When x approaches infinity, e minus infinity is negative infinity.
Negative.
Okay, and this is 1 over infinity to infinity, which is 0.
Perfect.
So when we go back up here, I should have mentioned this to you. Find a limit, use L'Hopital's rule where appropriate. If there is a more elementary method, consider using it. Good. Let's take a look at, let's choose another. Can anyone?
Could you take off the? Could I see the problem? Thank you.
Yes, it's this one. X raised to e minus x. Good. Will I choose the next one, or you will? We will have to look at at least one more of the powers. Okay, I like 67. Limit as x approaches 0 from the right, 1 plus sine 3x raised to 1 over x. Let me see how I am with time here. 16. Oh, I think I'm going to stop and start